Hello everyone and welcome back to the X Machines channel. Energy has become one of the world's most controversial issues over the last few years. Various countries are engaged in a race against the clock with a view to exploiting and developing renewable energy sources to replace the conventional ones such as petroleum, gasoline, and coal. Regarded as one of the most fast-growing energy sources in the world due to its many advantages, wind power has gradually gained public preferences. Wind turbine blade, an important component that aids in harnessing wind energy and driving the rotor of a wind turbine, has deceived many people for its simple appearance. In fact, blade manufacturing is not an easy job at all, since it has to meet a wide variety of conflicting criteria. This video will take us to blade maker and is now under the management of Fraunhofer IWES. Every blade manufacturing process starts with the designing state, in which CAD/CAM offline programming is performed by qualified and experienced engineers. In the next step, milling, integrated CNC controllers are needed to deliver precise milling. Besides, a 6 DOF movable process head, which enables 5-axis high-speed milling, is operated at a speed of 2.5 meters per second and acceleration reaching up to 4.5 meters per square. Once the milling procedure is completed, the process head will be replaced by the textile blanks for automatic grinding. In addition, 2 gantry robots for independent of concurrent operation are equipped to aid in the pick and place process for stack cuttings, large textiles, and sandwich preforms. Integrated quality management systems for large structure manufacturing are always available during the process. Have you ever wondered what a wind turbine blade is made of? The answer is composite materials are used typically in blades and nacelles of wind turbines, while generators, towers, etc. are manufactured from metals. Blades are the most important composite piece part of a wind turbine and also the most expensive component of turbines. Various technologies for wind turbine blade manufacturing have been applied. However, the steps carried out in each technology chosen are basically the same. Let's watch this simulation to have a general understanding of the manufacturing stages before visiting the factory. First of all, we have wind blade shell molds, which are then covered by a fiberglass layer. After that, prefabricated root reinforcements are applied to ensure the solidity of the blade. Following that, laser projection is performed. In the subsequent stage, prefabricated spar caps, pre-kneaded foam, and balsa core and a dry fiberglass fabric layup are arranged in order. Next comes the preparation for resin infusion with the vacuum bag applied above. Once epoxy resin fully saturates the fiberglass, the vacuum bag will be removed and epoxy adhesive will be applied instead. After the blade shades and assembled, the perimeter flashing will be trimmed away and ultrasonic inspection of bond joints will be carried out, together with the installation of leading and trailing edge reinforcement, rule face machine flat, platform and bolts. The blade will be painted and have to undergo final inspection before being loaded into the shipping saddles as the final step. Have you ever heard of one-shot blade technology, a familiar term in the wind blade manufacturing industry? This is a highly technological process using a single mold for the production of wind blades, ensuring the best result in terms of quality and avoiding micro cracks or leaks. Glass fibers and carbon fibers deliver an excellent result in terms of strength and structural integrity. One-shot blade technology also makes it possible to lower production costs and execution time. There is an interesting fact that LM Wind Power managed to set a record for the world's longest wind turbine blade twice. Let's look back to 1991, when the first offshore wind farm in the world was born with a LM Wind Power blade which was only 17 meters in length. In 2019, amazingly, LM Wind Power succeeded in breaking its previous record and unveiled the world's first blade beyond 100 meters. This is how the biaxial line.
This is what LM Wind Power has always been doing since 25 years already in offshore, and has continued to do that with the first landmark in 2006 with the 61.5, then 2011 73.5, and 2016 88.4.
This is how the biaxial rotor blade fatigue test works. Wind turbine blades are usually tested for fatigue in separate tests for two main directions, so-called edge and flap directions. Performing both tests simultaneously is an obvious idea, as this can lead to a quicker test and loads closer to field conditions. The new approach is using decoupled masses and spring elements to tune the natural frequencies of the test system. This way the blade tip moves in an ellipse. Mass and spring elements modify the frequency and load distribution over the blade length. An extensive numerical optimization process is required to find the ideal test setup. A successful demonstration in 2020 shows great correlation between numerical prediction and physical behavior of the system. The induced loads of the test agree well with the required target loads in all directions. Transporting wind turbines is not an easy task. Relocating wind turbines can take close to a year of planning and up to 10 loads. Many turbines are manufactured domestically and abroad. However, they are usually trucked to their final destination. When talking about a wind turbine blade transport trailer, the components consist of hauling a wind turbine, including wind turbine blade size, towers, and more. And now, let's take a look at the world's first wind turbine blade beyond 100 meters, built by LM Wind Power, and see how it was manufactured and transported to the desired location. The 107-meter blade has completed the molding process at the factory in Cherbourg, France. The LM107P will now proceed with post-molding finishing touches before undergoing rigorous testing and validation to demonstrate its ability to withstand more than 20 years of operation offshore. The 107-meter blade is set to capture the wind for GE's Haliade X12 MW offshore wind turbine. the world's most powerful wind turbine to date. Restoring and maintaining wind turbines is considered the most dangerous job ever. The maintenance of wind turbines takes place at predetermined intervals, usually once or twice a year, whereby all important mechanical and electrical assemblies are checked. On average, this requires about 20 working hours. Technicians handling this job are likely to suffer from falls and other unexpected accidents, not to mention the exposure to harmful gases, vapors, and dust that can occur during blade maintenance, including puffing and resurfacing, with greater exposure likely due to confined working conditions. This is the end of the video. Thanks for watching. Please leave a comment for a deeper discussion on this topic, and don't forget to subscribe to the channel so you don't miss other interesting and useful videos from the X Machines channel.